Hi everyone, my name is Mesfer Alajmi. I'm a PhD student at Math Department. The title of my talk today is Evolutionary Game Theoretic Approach for Modern and Decision Treatments of Colon Cancer. In fact, over the past decade, research has shown that chemotherapy with a maximum tolerate dose, MTD, fails to destroy cancer cells due to the evolution of resistance in colon cancer. Also, adaptive therapy is more effective than MTD, as we see in figure 2, but it aims to increase survival time by making colon cancer into a chronic condition. To overcome this issue, we develop a new evolutionary mathematical model of colon cancer and formulate a new evolutionary game between the oncologist and colon cancer. Also, we investigate Stackelberg and Nash solutions to determine the best possible outcomes for the patient. Okay, so our model's objective is to provide a description of tumor growth, immune system response, and adaptive treatment. Actually, this model comprises 3 ODs, as we see, and this system of ODs helps us understand the interaction that could happen between the cancer cells, lymphocytes, and the chemotherapy. To improve the stability of numerical algorithms, we non-dimensionalize the model. Now, to build our game, we consider 2 optimization problems of the oncologist and colon cancer subject to our model. So we have argument GP over omega-1, where omega-1 is the set of the strategies of the oncologist, and argument GC over omega-2, where omega-2 is the set of the strategies of colon cancer. Actually, the oncologist is the only rational player in this game, so he can be a leader. And since colon cancer plays this game by adapting, we consider it as a failure. So in this scenario, cancer treatment has become the Stackelberg game. If the oncologist plays the game with colon cancer at the same time and keeps applying the treatment over and over without any observation of the cancer's moves, this results in the Nash game. To verify these solutions, we have our numerical results. In figure 2, we have an illustration of the Stackelberg solution. So, as we see, the total number of cancer cells in graph N has completely disappeared due to the oncologist response U in graph UP to cancer resistance. But the oncologist will keep to apply the best treatment strategies to eliminate any remaining cancer resistance, as we see in graph UC, and to prevent the tumor from growing again. Also, we notice that the graph of lymphocytes is decreasing, and that's because the lymphocytes is involved in the fight of the cancer. Also, because the consequences or the side effects of the treatment. Next, we have illustration of the Nash solution. We notice that the oncologist keeps to administer a higher doses of chemotherapy without adjusting the treatment plan or observing how the cancer cells are responding, as we see in graph M. Therefore, or as a result, cancer spreads, as we see in graph N, because the cells are able to successfully adapt to their environment. Finally, we conclude that our results show that Stackelberg strategies are desirable to destroy cancer cell evolution and advancing evolutionary treatments which will enhance patients' quality of life. Thank you so much for your listening.